The first way to make your code work faster is review it in terms of memory preallocation. So we have already discussed that Matlab differs a little bit from other programming languages in a way that usually you don't have to declare the type of your variable in advance. It can be created and declared at the same time when you define its first value. However, even though most of the operations can be executed without preallocation of sufficient memory, then smart preallocation of memory, in cases when it is possible, is a time-saving effort. So you can actually improve the speed of your code relatively significantly. Let's have a look at a simple example of a code. So here's a code with no memory preallocation. So what we do, we would like to declare that we will be generating a bunch of numbers. That's actually 100 million. Then we actually do generate those numbers. So we use the function rand. And then we would like to create vector z, which is equally long as our y vector, but it contains the y vector multiplied by 2, or the elements of y vector multiplied by 2. So this code written like this, and with this value of n 10 power 8, takes about 11.5 seconds on a computer which has 16 GB RAM and i7 processor. So it's quite a bit of time, and if you dare to increase that power 8 to power 9, then that time actually increases to over 400 seconds. If you have something yet bigger to calculate, that may be even worse, or it will be much worse. However, we can pre-allocate memory, because what happens in this code that we looked at, every time Matlab creates the next zi, so first it's z1, just as the loop goes, then it is z2. Since that second element doesn't exist yet, Matlab kind of checks how many z elements we have until now. Okay, it's 1, and now they are telling me to create another one, so I have to make space for it. So it makes the space, and then it assigns the value. So it's like an extra operation for Matlab to actually check the actual size of z and then assign the new value to the new space. If we would like to pre-allocate memory, the most convenient way is to use one of those functions like ones or zeros. Because in this way now, what happens is that, again, we decide how many numbers we generate. We do generate our initial vector y. And then we tell Matlab, create all at once, or all at one go, vector z, which is also sized 1 by n. We could have also written z once, and then in here put size, maybe size y. Maybe it's even more elegant than 1, because you may make a mistake, maybe accidentally put here something else. But we do want vector z, which is sized equally with y. So this is the best way actually to write it. And then we again have a loop to do this operation. So this code, when we did pre-allocate memory, so once again it is this step exactly, or this one, it takes 3.4 seconds. So when compared to 11.5 in previous case, that is like a third. And if again we dare to increase this number of numbers to actually 10 power 9, so 1 billion, the code runs for 159 seconds. Well, it's not 10 times faster, but it is like 3 times faster, or 2.5. So that is an improvement. And that's why whenever, especially if you do something in for loop, where you know what will be the size of your resulting vector, resulting matrix, it is better to define it first, as for instance just zeros and ones, because then Matlab already knows what to work with and it doesn't waste time on checking and extending things.